Hello. I'm having to check this thing. First of all, I wanna be sure whether I'm live or not. The last time I tried to be live, but it failed. Actually, I couldn't be live just a while ago. And right now, I'm trying to be back, but not sure like what's happening. Okay, turns out that it is working fine, so I can just simply click on this. As for this network issue, let me fix this. Okay, I'm just trying to get it fixed. I hope I'll be back online, like live soon. I'm already live, but not sure with the proper way or not. So let's see. It's gonna be connected soon. At least that is something that I hope. And it's my bad luck or what? I mean, I've been online for 1 hour, 1 minute and 20 seconds and all, and it's not showing the result, any result over here. Interesting. I do have the good network connectivity, still I'm not being shown over there. Like it's saying that connect your encoder to go live. Oh, finally, dhanyavad. Yaar, nothing could be better than this, that I'm live right now. Alrighty, let's continue from here on. Right now I'm live. That simply means I can just simply go on. And one more thing, I will be turning off the chats. Unfortunately, I'm having to do that. Even if I turn it on, no one comes. So never mind, it doesn't really matter. By the way, I was working on this WhatsApp clone. Again, the work is in the process and something like that. Let's close all of them. Apart from this particular thing, I'm gonna be closing this as well. And when it comes to this WebRTC, so the main project is here. And let's simply have a look at this exactly how many things I've covered so far and how many things are actually remaining to be covered, right? So let's simply go through it. So far we have actually done many things. One of those things are like attaching the local stream. Once that is done, then from here we are implementing with WebRTC. It's kind of, there are some kinds of sets of protocols that we have to follow. First of all, WebRTC configuration. This is gonna be the configuration, and when it comes to the configuration, so we are getting the message. I hope that was from this person. I am doing it's okay. I got the message from that guy. I will be just like replying later, because right now of course I'm busy. So iServer. So first of all, we got the iServers over here, and the thing is that, or how it works, I'm using these iServers over here, so kind of stun servers, so that even if you do something after some days, then you start forgetting the things as well. By the way, this is the WebRTC configuration. Then over here I'm just simply specifying my stun server, so that it can just simply send a request to the stun server, and stun servers are gonna be simply giving me my public IP address, and private address, private IP, public IP, private port number, public port number. It will be giving all these things. And by the way, this is the first way to write this. Like first of all, you can say iServers, and URL is gonna be this for that, and the second URL is gonna be this. So ultimately you can provide the URLs like this, or you can even provide the URLs like this. Like over here you just have an array and you are just simply doing this. By the way, if the stun server is not running or available, another one will be used. So inside iServers we are providing the stun servers URL. Why are we doing that? So that my iServer can actually send a request to the stun servers, and stun servers are gonna be returning the data back. In case you were using turn server, just an example, like in case if you were using that, so this is how we can just simply use that. By the way, not using that right now. And WebRTC configuration, WebRTC configuration object I'm giving it. Inside this I'm just simply specifying the iServer, and iServer has the URL of the turn server. Okay. I will be taking the help of the AI to just know the flow better, but overall things are great. Ultimately what happens over here, that whenever, let me even talk about this later once everything gets done. Okay, and then I have my RDCP add event listener. I'm just simply adding the event listener. This negotiation needed runs only when something changes in the offer and all, or something changes in the PC, like peer connection. And over here local stream get tracks. So ultimately I'm getting all the tracks, and I'm just adding those tracks, and whenever those tracks are added, it simply triggers this particular function, and it just simply runs. And once it actually runs, then what happens, I create the offer, and once the offer is created, I simply set the offer to the local description and all. So this is the only thing that's happening right now, nothing too much. Then listen for ICE candidates gather or PC on candidate. By the way, this is also one of the ways, or you can listen to the ICE candidates like this. PC add event listener ICE candidate, and it will be running. So what is the flow over here? First of all, of course, you are giving it the configuration, and also once it has the configuration, so it knows that where the instance server is, and later whenever it's needed, it will be making a request to the instance server. Instance servers are gonna be sending the response back. By the way, the big question is that when does the instance servers return the response and all? We will be talking about that very soon. But whenever this track changes, like whenever this PC peer connection changes, you are adding track, so it changes, of course, so it will trigger the negotiation error function, and that's it. After that, you are even getting the stats over here once you've got the stats. And once this negotiation error function gets triggered, ultimately the offer gets created, the offer gets even added to the local description and all, and that's it. At the end of the day, you are just simply, and as soon as the offer gets created, this ICE candidate gets triggered too. Like, this is the overall what kind of flow I can say. By the way, let's continue from here on and see exactly what's gonna happen just after this. Okay, apart from this particular thing, I have a lot written in my notes, so let's simply go through my notes right now so that we understand it even better, right? Coding the code, software, and I will try to do my level best so that I'm actually going through many things in a day. Like nowadays, what is the situation that I learned something today, then I will get the chance to learn that thing again after 2 days, or maybe after a day at least. So right now I'm going through WebRTC today. There's very less probability of going through WebRTC again tomorrow, and because of this thing, I just forget the things, and then I have to revise that. This is the problem that I have to fix, and the solution is pretty simple, that give you overall so that you can actually go through it all in a single day. Right, as simple as that. Let's simply go through my notes right now. And in my notes, I have my ICE candidate, I have my instance servers, and that's it. Let's go through the instance servers, and simply right now I'm gonna be having a quick I'll be just simply going through it quickly, and then after that I'll be just thinking, okay, because once I have the knowledge, then I can think better. Okay, by the way, public instance server list, from here you can actually get the list of servers. A simple server that tells you who you are. Okay, instance servers have one task: check the IP and port address of an incoming request from a device running behind net, and send that address back to the response. This is actually happens, so it does nothing. It simply gets your IP address and port, and it simply sends you the response back. Instance servers don't have to do much, so relatively low spec instance servers can handle a large number of requests. That's why they are free. Okay, so what happens that this is my laptop, and again I'm on my Chrome on my laptop, and then from here this is the instance server. I will make a request to the instance server will simply send me the response. So private IP address assigns new port. So ultimately over here I have my private IP address on my laptop, of course on Chrome, and I have my private IP address. Then what I do, I just simply send a binding request to the instance server over UDP. It can be UDP, yeah, most of the time it is UDP. What is my public IP address and port as seen from the internet? So when I send a request to, I have my private IP address, right? I have my private public port, right? Private port, right? Now when I send a request to the instance server, so instance server will get like, okay, you are sending from there, this is your public address. So from instance server's point of view, it will actually get the public address, and that's the same it will return. So response with the binding response XOR mapped address, but ultimately it will be returning the public address as well as the port number. How does it get the public address? It's simple. Like if there is a router, so your router has its own public address, right? And then your devices the device that you use, that has its own private address. So your mobile may have its own private address, and your router will have the public address. Then there is something called NAT, N-A-T. Again, I don't remember the full form, forget about that. But what it does, that router with the help of NATs, it simply maps the things. So the public IP address will be mapped to the private IP address. And whenever you send a request, so ultimately public address, your private address and public address, they are mapped. So whenever you are sending a request to anything, so ultimately your public address also gets sent along with that. And when the public address gets sent along with that, so the last one that receives that request over here, instance server receives this. So instance server gets your public address. Once the instance server got your public address, it will be sending you the response back. So in the response you will be getting four things. First, private IP address, private port number, public IP address, public port number, and again many more things, but this is how it should be going on. By the way, a term binding refers to the association between the client's private IP address port and the public IP address assigned by the net. Yeah, I was just simply saying that public IP address or port assigned by the net, ultimately they are mapped together and net just gets the job done. The instance response effectively binds the client's private IP address to its public address and recognized by external entities. It's as simple as that. If there is your device, it will have the private IP address, it will have the public IP address. What will the stun do? It will, because once we send the request, your private IP address, private port number, public IP address, public port number, they will be sent, and once they are sent, then the receiver over here is stun server, it will just simply recognize that, it will send you back, as simple as that. By the way, the stun response effectively binds the clients. It simply binds them and simply recognized by external entities. Once a client received a public IP address for itself from the stun servers, it can then send these details to the other peer via signaling. That's right. Other clients need to know your public IP address in order to initiate a connection with you. Other clients need to know your public. It's simple, right? There are gonna be two people, and I'm because they are logged in or something, they are on a website, that means they are logged in, that means I can signal them using WebSocket. So if I actually signal them with the right data, that means if they use the same data, they will be able to connect to my device. That simply means I will be able to talk to them. I will be able to make a WebRTC connection, and I will be able to make a video call, or I will be able to make an audio call. It's fun, but yeah, this is how it goes. When two clients receives your ICE candidates, it can attempt to connect to your device using those IP address and port number. That is right. Each connection between two devices is identified by a unique combination known as 5 tuples, which includes source IP, destination IP, source port number, destination port number, transport protocol. That can be TCP, that can be UDP. Most of the time that is UDP. How good thing this is, and this is pretty simple. If you want to connect it to somebody, if right now we are mainly talking about the clone of WhatsApp, because I will be working on that. So whenever you want to connect it to that particular person, so on WhatsApp, because those people are already logged in, so whenever that person comes online and whenever you are online, or most of the time when you make a call, so when you click on that, okay, click, who is texting me? Just a sec. Okay, Prabhat, by the way, it's good thing if you haven't done that. Update control statements, and wow, he's actually doing a great job. Glad to know that. Alrighty, by the way, let's continue with the things. People are sharing their learnings. I haven't done any, so I'm not sharing right now. How does the router know to connect with your private network IP? When a connection attempt is made to your router's public IP address, this at port number, this your router uses net to determine which device on your local network should receive the traffic. As simple as that. I mean, router has the mapping of your private IP address and the public IP address, again using the ports and all. And then router just simply determines like which IP device should be getting the things and all. By the way, inside the ICE candidates, the ICE candidate, whenever they are triggered, I get some response, and in the response I'm getting my candidate, I'm getting this ID. Again, there are many things, one UDP and all. Okay, and not only that, inside this I'm getting the Radar 192. So ultimately this is the public IP address, and this is the private IP address that I have, and this is the public port and this is the private port. How do I know that? I will show that, but yeah, this is how it simply goes on. Again, this is we get it inside our ICE candidate, so that's fine. Again, this is the public port phone number mapped by your router via net that can be used to establish WebRTC connection. The router itself does not own its port. Instead, it performs net mapping to forward traffic from its public IP address to the port corresponding private endpoint of your local device. This is created dynamically by WebRTC's ICE process using techniques like stun and hole punching. Okay, we have candidate ICE. This is the ICE candidate. We have this number, foundation, group, similar candidates for priority decisions. Foundation groups similar candidates for priority decisions, so simply groups them. One component ID, usually one RTP, one usually one is equal to RTP, 2 is equal to RTCP. Okay, UDP transport protocol, this particular thing priority value, then this is the IP address being offered, that means the public IP address, and this port number, T type suffix, this is surfLX, okay, or SRF LX suffix or not. Candidate is gonna be server reflexive, and then related address, that is gonna be the private or local address, that's gonna be this one. Similarly, related port number private, generation life legacy field Chrome specific, usually always 0. Ufrag username, ICE username fragment used during connectivity checks, network Chrome specific network identifier Wi-Fi #2 is being used right now, and network cost indicates the cost lower better than often circular. Sorry, let's continue. Failure of Eastern. Even though the client still receives your candidate, sometimes net might still block connections. That can be because of double net, complex net types, blocked protocols and ports and firewalls and all. And because of all those things, I mean, ultimately it can be blocked. So what happens is that client, my laptop has its own private address, and then using the router, it gets simply its own public address, and then performs net translations to the public IP, and then the ID is actually sent over here, and it gets its own private address and public address and all, and router 2 just simply performs net translation again, and ISP gateway public, this it just simply stops and all. Ultimately the request will be stopped. Private IP address performs, public IP address will be sent ISP gateway. Turn servers are gonna be used over there when all else fails. If Eastern fails, the browser will initiate a connection with the turn server credentials. If Eastern fails, the browser will initiate a connection with the turn server credentials you supplied in the configuration field of the RDCP connection. When the browser sends a request to a turn server, it follows the turn protocol. This protocol involves specific message types such as allocate request, which tells the turn server to allocate a relayed transport address client. So far so good, it hasn't been quite bad. The thing is that first of all, you specify your this configuration over here. So ultimately Eastern server's address URL is specified over here. So whenever offer is created, this particular ICE candidate gets triggered, and when it gets triggered, ultimately you get a request gets sent to the Eastern servers, and you get the response over here. It's just as simple as that. By the way, as for this, that was it actually for now. Now I'm gonna be catching up tomorrow, and I will actually start learning from here on. Okay. I should be just calling it a day right now. Take care and see you soon. It's just been 18 minutes, I know, but okay, it's quite night, so I will be just calling it a day right now.